Hello everyone and greetings from me, Diana Martin, and my colleagues Eddie Cullen and Brian Bowe from TU Dublin. We are very glad to be part of this year's Forum on Philosophy, Engineering and Technology and meet you all virtually. Today we will be presenting you the results of our study, which examines how engineering instructors in Ireland view the scope and goals of engineering ethics instruction. Before we begin, a brief outline of our presentation today. We start with a description of the different theoretical models for engineering ethics education proposed in the literature, before moving on to a description of our research study, followed by a presentation of our findings and a discussion. You are more than welcome to join the conversation at Slido, code 17902. First, we wanted to explore how the scope and goals of engineering ethics instructions have been articulated in the literature. As Hess and Ford point out, there are multiple ways in which engineering ethics education has been defined. Drawing on sociological theory and debates within the discipline, we put forward a framework for understanding the different understandings of the scope and goals of engineering ethics education, which is based on 4 levels of analysis emerging from the interaction of two social continua. First, the micro and macro distinction refers to the magnitude of social phenomena ranging from individual action to a societal outlook. Second, the objective-subjective distinction refers to whether a phenomenon has a real material existence or exists in the realm of ideas. This quadrant model aims to move the focus away from the scale of issues addressed in engineering ethics instruction, which is a focus of the micro versus macro debate, and emphasizes how different mechanisms operating at different levels come together to produce particular effects in the practice of engineering. In this, the commitments of engineers and the goals of the profession matter, but so does the context in which engineering takes place. Thus, the quadrant model suggests that the key analytical focus should be on the relationship between the agency of engineers and the social structures they are part of, as well as on the extent in which these structures constrain or enable ethical engineering. We will have now a brief look at what each of these 4 different models entail for engineering ethics instruction. The microsubjective model is considered to be the dominant approach in engineering ethics instruction, and the main focus is on the consciousness and commitment of individual engineers and their ability to identify and solve ethical dilemmas. There is an emphasis on the use of case studies to develop moral reasoning and prepare students to solve ethical dilemmas, which often involve routine engineering workplace scenarios. Topics such as professional codes, ethical theories, and whistleblowing tend to feature prominently, and there is an assumption that conditions exist for engineers to assume moral responsibility, with codes of ethics seen to be standards of responsibility. For the micro-objective approach, the focus is on why accidents happen, and the explanation is usually sought within the prevailing organizational culture and processes, with exemplary work being Vaughan's 1996 analysis of the Challenger disaster. Lynch and Klein draw further on Diane Vaughan's analysis to argue for a focus in engineering ethics on the detail of engineering practice and the role of organizational culture and processes. Their aim is to explore how engineers can learn to identify features of their practice that potentially contribute to ethically problematic outcomes before clear-cut dilemmas emerge. They propose that engineers should exercise imagination to prevent these problematic characteristics from developing in their practice. The approach thus aims to move away from simplified case description in order to include organizational details and social context. The third model identified is a macrosubjective model, which enlarges the horizon of inquiry to encompass the broader mission of the engineering profession. Drawing from the philosophy of technology, Son argues that a shift to a macro focus should lead to a questioning of the goals of engineering or current forms of technological development. such that engineers will be obliged to reflect on what kind of society is desirable to produce sound arguments for their ideas, and to conduct and justify their engineering practices accordingly. In this spirit, Bowen calls for an aspirational ethics within engineering which prioritizes human flourishing and contributes to human well-being. While engineers may be committed to ethical practices, it is not always possible to behave ethically, such that there is a danger of moralism. To exercise moral agency, commitment to particular outcomes is necessary, but so is the power to achieve them. This highlights the need to raise the level of analysis as to address the broader goals of engineering and also the capacity of engineers to practice engineering in a way that promotes human flourishing and addresses grand societal challenges. At the heart of the fourth macro-objective approach is a demand of Zandvoort that engineers need to accept that they must play an active role in helping to reshape the context from which ethical problems arise. The approach endorses the view that current context in which engineering takes place might place limits on engineering practice and the capacity of engineers to exercise social responsibility. For some thinkers, engineering appears as a captive profession in which engineers face a key contradiction as they struggle, in the words of Noble, to attain professional autonomy and define standards of ethics and social responsibility within a context of professional practice that demands subservience to corporate authority. We can identify two broad and overlapping approaches to facilitating change in the environment in which engineers work. The first would seem to accept that the current organization of production and consumption can be reformed through regulation to give support to engineers. Some approaches to engineering ethics have focused on specific changes in the structures of corporate and management accountability, and Zandvoort, for example, proposed a wide range of changes to legal systems that would enable socially responsible behavior in engineering and the promotion of sustainability, including a regime of strict liability. The second approach questions whether the goals of sustainability and social justice can be met within the confines of current relations of production and consumption. Petrella, for example, argued that legal reforms are not enough and that we need a wider focus, as there are contradictions between the goals of engineering, such as sustainability, and current political and economic priorities. Nussma stresses that by catering to economically powerful groups, market-led design practices create even more products while leaving the many basic needs unaddressed. In this context, the requirement to practice and promote sustainable development at a global scale has lent weight to the demand to focus on unmet needs, social equity, and community engagement, and for the profession to influence change in social, political, economic, and institutional paradigms, increasing the ability to move in sustainable directions. Finally, it is important to note that none of these models is considered superior to the other, and all of them are needed in order to provide a comprehensive and holistic engineering ethics education. Given the diversity of approaches and how engineering ethics education has been conceptualized in the literature, we aim to examine how engineering instructors define the subject of engineering ethics education and what they consider to fall under the scope of engineering ethics instruction, as well as the goals envisioned for this. In our research study took part 23 engineering programs from 6 higher education institutions across Ireland, which underwent accreditation between autumn 2017 and spring 2019, including 16 instructors teaching in these institutions, as well as 5 evaluators serving on the panels of Engineers Ireland. For the results that we will be presenting you today, we employed qualitative methods such as interviews with the instructors and evaluators, document analysis of the documentation submitted for accreditation, which includes a description of the program goals, as well as participant observation at accreditation events. The process of analyzing data underwent several iterations until it generated a first codebook of content areas, goals, and definitions of engineering ethics education. During a second iteration stage, this was subsumed under 5 main definitions of engineering ethics education, 7 content areas understood to fall under the scope. as well as 11 goals. The first question we are exploring now is, how is engineering ethics education defined? Don't forget that you can join the conversation at www.slide.do, and the code for the event is 17902. As mentioned previously, the responses have been coded and subsumed under 5 major definitions of engineering ethics education. To the right of the screen, you can see an example standing for each definition. First, engineering ethics education is understood to be socially embedded. As one participant said, ethical practice is part of social dynamics to some extent. Engineering ethics education is also understood as character shaping. Some of the virtues highlighted by the participants interviewed point to intellectual discipline, courage, and empathy. Thirdly, engineering ethics education is understood to be about decision making in complex situations. As one participant said, when you are taking technical decisions, you are inevitably also taking decisions which impact on people, your colleagues, society, and the environment. Engineering ethics education has also been defined as being close to engineering practice. Finally, the subject has been defined as common sense and obvious by appealing to a person's moral compass and inner knowledge that certain things are good or bad. It is now time to open this question to you and ask you with which definition you agree with. The highest number of responses defined engineering ethics education as being about decision making in complex situations, followed closely by an understanding of the subject as being relevant to engineering practice, character shaping, and socially embedded. Only one respondent defined engineering ethics education as being common sense and obvious. Moving on now to our second question about what falls under the scope of engineering ethics education. We are looking forward again to your input at Slido, code 17902. 7 major areas have been identified by the participants as falling under the scope of engineering ethics education. Again, to the right of the screen, you have an example for each content area. Engineering ethics education has been understood as being about health and safety, as well as about regulatory and legislation issues, such as protected disclosures and whistleblowing. Other content areas include stakeholder perspectives, given that significant issues are going to impact not just the stakeholder who you are working for, but also the community where that stakeholder is. Ethical theories, such as the distinction between morality versus ethics, environmental theories comprising both the Western and non-Western perspectives, professional codes, such as Engineers Ireland's Code of Practice and also the canons of the American Society of Civil Engineers, values in design, such as the ergonomics of how a product is used, given that it affects the welfare of users, and finally, societal challenges, most mentioned being those of sustainability and globalization. We are looking forward to your responses at Slido about what content areas you use to teach engineering ethics. You can see that professional codes received the highest number of mentions, 13, followed closely by content areas related to the perspectives of different stakeholders and societal challenges. The lowest number of mentions, 5, have been received for content areas related to values in design and regulatory and legislation issues. The first question we asked was about the goals and vision for engineering ethics education. Here, our analysis identified 11 goals and vision for engineering ethics education, those of upholding professional standards, recognizing and solving ethical dilemmas, developing an appreciation of the importance of ethics, knowledge of ethical theories and vocabulary, encouraging value-based design, fostering responsibility in engineering practice, enabling agency and student empowerment, developing broad and self-critical thinkers, dealing with complexity in a globalized world, gaining an appreciation of the broader context of engineering, and encouraging perspective taking. Again, we are waiting for your input at slido.com, And we are looking forward to hear what are the main goals you set for engineering ethics education. Please choose the 3 most important goals that you use in your teaching. We can see that the most popular goal and vision for engineering ethics education is that of fostering responsibility, with 14 mentions. It is followed closely by the goals of enabling agency and empowerment and developing broad and self-critical thinkers, each receiving 9 mentions. While the least popular goals are those of raising awareness of the broader context of engineering and exposing students to the complexity of a globalized world, with 3 mentions each. According to the participants of FPET who responded to our poll, the 3 most popular goals appear to be those of developing broad and self-critical thinkers, fostering responsibility in engineering practice, and raising awareness of the broader context of engineering, while the least 3 popular goals are those of developing appreciation of the importance of ethics, developing knowledge of ethical theories and vocabulary, while nobody opted for the goal of upholding professional standards. Based on the program goals described in the documentation submitted by the participant programs for the purpose of accreditation, our analysis identified 7 institutional goals related to ethics. The graduate aims set by the institutions participating in our study in connection to engineering ethics education target fostering responsibility in engineering practice, which was a goal set by all 6 institutions, followed closely by upholding professional standards with 5 mentions. With 2 mentions, we have the goals of developing knowledge of the regulation and organization of the profession and developing a holistic vision of engineering. With 1 mention each, we have goals related to customer and user orientation, compliance with existing legislation, and personal development. Our investigation revealed a varied understanding of engineering ethics education, more so at individual level than institutional level. The formulation of the goals of engineering ethics education set by instructors covers all 4 models of engineering ethics education identified based on the literature, while institutional goals are more fitted with the microsubjective and objective approaches. We also found that engineering ethics is preponderantly defined through its connection to engineering practice, rather than in its theoretical dimension, in line with findings of Godfrey and Parker and Hess and Ford. The emphasis on the embeddedness of ethical decision-making in context of practice that require careful deliberation and critical reflection recalls the intellectual virtue of phronesis, as suggested by virtue ethics theories. Other virtues mentioned in connection with the goal of character development are discipline, courage, and empathy. We also noted that instructors aim to familiarize students with value-based design in a lesser extent compared to other aspects deemed to fall under ethics. Finally, a challenging aspect revealed by our study was related to identifying the ethical dimension of a topic, especially in connection with issues such as safety and legislation, which have been considered as related or not related to ethics by different respondents or instructors from the same institution. This was mostly visible during accreditation events when conflicting views on whether a topic purports to ethics has been expressed by instructors and accreditors. This leads us to suggest that further research might be needed on how instructors understand the topics falling under the scope of engineering ethics education, as to identify where the challenges arise. We also recognize a need for further empirical research that could explore the curricular alignment between goals, topics, and teaching methods employed in engineering ethics instruction. Thank you for your attention, and I would be more than glad to get in touch with you if you have any questions or comments at my email address dianaadela.martin@tudublin.ie.